So now we're looking at thinking with math models, investigation 2, problem 2.2. And we're looking at, again, linear relationships. We've been looking at those throughout this book. And so now we have a situation where we have a car wash that charges by the minute, and the table shows the time and the charge. So you can see that for 5 minutes it's $8, 10 minutes $13, and so on. And so we know that this is a linear relationship because it always goes up by the same amount each time. This goes 8 to 13, which is a change of 5, and a change of 5, and a change of 5, and a change of 5. Linear relationships are always identifiable by a constant change in x compared to a constant change in y. This one goes up by 5, this one goes up by 5, this one goes up by 5. So we have that constant change in this. And so we can actually find a slope and a y-intercept as a result of that. The slope is the change in one value compared to the change in another. And really we have to think of things in terms of x and y. So if we look at the time as x and the charge as y, and I'm going to kind of rearrange the chart so it's this way. So if our x is 5 and our y is 8 and our x is 10 and our y is 13, so all I'm doing is taking this chart and kind of turning it the other way, going up and down with it. And then our x is 15 and our y is 18. And that's really all I need. I have more information than is necessary because what I want to look at is how does this change compared to this change. This change is up 5. This change is up 5, which means the change in y is up 5. The change in x is also up 5, which means they're changing by the same amount. They're both changing by 5. They're both going up by 5. So really the slope, the change is 1. It's a one-to-one relationship. As this goes up really $1 or 1 minute, this goes up $1. We're just going by increments of 5. So at $6, this is going to be $1 more. And at 7 minutes, 8 minutes, 9 minutes. So that you could fill in blanks. We could actually have more numbers in the table. The question, really the important part, is what if I went back to 0 minutes? That's an important point on any graph. The 0 point of x is an important point. So this is going to continue backwards as well. If this goes 8 to 13, this is going to go backwards 8 down to 3. And that's an important number right there, because that's what we call the y-intercept. That's where x is 0 and y is 3. And so what that means when I write an equation, which is what I want to do, slope and the y-intercept. So I got the slope is 1. And the y-intercept is actually the point 0, 3, or we actually would just say the y-intercept is 3. So those are two important pieces of information, because now I can write an equation, y equals, in this case, the slope of 1, or 1x, 1 times x, plus 3. Which should make sense, because if I go x plus 3, x plus 3, so 15 plus 3, 10 plus 3, 5 plus 3, 0 plus 3. If this is my x, and I add 3 to it, I get the y value. And so that is the equation for this data for the squeaky clean car wash charges. I know that whatever the amount of time is, 10 minutes, 20 minutes, 30 minutes, I'm going to take the time and I'm going to add 3 to it to get the total. And really it's saying it's $1 a minute plus the $3 up front. All these things on this mean something. there really could be a 1 in there, 1 times x. That's the $1 per minute charge plus sort of a $3 upfront cost. You just pay that no matter how many minutes you use, it's still going to cost $3 plus $1 a minute to get your total cost. So this is again like an upfront or an initial fee. And that gives us problem 2.2, 1, 2, and 3. We've got to explain that it's linear, showed the slope and the y-intercept, and we wrote an equation, in this case the charge and time. So I could put it in those terms too, that the charge is equal to the time plus 3. Just different variables means the same thing.